What's up, Math 1 students? Welcome back to our next video. We have 4.6 for you today. Here we're going to start solving inequalities. All right, it's very similar to solving equations with a slight difference. I know we usually skip this kind of first page, but we're going to go ahead and take care of it today in the video so that we can really hopefully see what's going on and get the major idea, or one of the major ideas from today's video, okay? So we're going to use this inequality in each of the following rows, and we're going to perform the following operations, okay? So I start with -9 is less than 6, which is a true statement, right? A negative number is less than a positive. When I add 3 to both sides, I end up getting, well, let's see, -9 plus 3. So we have -6. 6 plus 3 is 9, okay? And so that didn't change, right? -6 is still less than 9, which means that this resulting inequality is still true, okay? I'm gonna have to write a little smaller here. Okay, so as I move to the next one, and again, I start with -9 is less than 6, all right? And I probably should have done on the first one. I'm gonna draw my bar down the middle. Instead of adding 3, now I'm gonna take away 3. Okay, I'm going to subtract 3 from each side, okay? Well, what happens? -9 minus 3, -12. 6 minus 3 is 3, all right? Less than symbol, excuse me, bring it down. And -12 is still less than 3, so this one is also true. Let's keep going. All right, when we take our inequality, -9 is less than 6, and now we times both sides by 3, well, what happens? -9 times 3 is -27. 6 times 3 is 18. Okay, -27 is still less than 18. This is still true. What are we doing here? Okay, let's keep going. Okay, -9 less than 6. Now, when I multiply both sides by -3, let's take a look at what happens. I get -9 times -3 is positive 27. 6 times -3 is -18. Uh-oh. 27 is not less than -18. Something happened there. This one is not true anymore. Okay. Let's continue on. When we divide both sides by 3, I have -9 less than 6. When I divide both sides by 3, I get, well, let's see, -3 is less than 2. Oh, we're back to true, okay? We're back to true. All right, last one. I take -9 less than 6. I divide by -3. -9 divided by -3 is positive 3. 6 divided by -3 is -2. 3 less than -2. Oh, no, that's not true. That's false. Okay, and so when we kind of zoom out and take a look, we see that the falses occurred when what? Our falses occurred when we worked with negatives. All right, and so that's a major takeaway from today's lesson. All right, and so here we go. Let's get into some notes. Solving inequalities is the exact same thing as solving equations, except for when we multiply or divide by a negative value, or negative number, excuse me. You must flip the inequality symbol, right? To make these statements true, I really should have written what? That 27 is greater than -18. Or 3 is greater than -2. I needed to flip those inequality signs, okay? So that's the takeaway. All right. Now, real quick, in case we didn't learn it in last lesson, please remember that when you're graphing, whenever there's a less than or a greater than sign, okay? Less than or greater than, you keep your circle open on the number line. But if you have less than or equal to, or if you have greater than or equal to, you're going to go ahead and you're going to close your circle, okay? So let's take a look at a problem, an example, and see what's going on. All right, so everything kind of starts the same. I draw my bar down the middle. Let's see here. I'm going to take away x from both sides, right? When I have variables on both sides, I have to collect them somewhere. Okay, so I cancel out x on the right. So now I have 5 minus 4x is less than or equal to 13. Okay, we're getting there, we're getting there. I'm going to go ahead and, let's see, I gotta move this 5. Okay, I'm gonna take away 5 from both sides. So when I do that, let's see here. Oh, the 5's cancel over here. I'm left with negative 4x is less than or equal to 13 minus 5, 8. Okay? Final thing, let's see here. Oh, I got to get rid of the negative 4. It's negative 4x, so I need to divide both sides by negative 4. All right? And when we do that, we get x. We get 8 divided by negative, we get negative 2. Okay, but here's the thing. This is the whole thing. This is what makes it different than an equation, right? Because we divided by a negative, we must do what? We must flip the inequality. All right. So instead of using less than or equal to, I'm going to say greater than or equal to, and that is my final answer. Okay? You know what? I'm just going to go back and add this really quick to my notes. Remember, when I say flip the inequality, I mean a less than becomes a greater than becomes a less than, or a greater than or equal to has to kind of flip-flop with a less than or equal to. Okay? Okay. So let's just do some problem. Oh, wait, I forgot to graph. What am I doing? Okay, we're supposed to graph this as well. So let's go ahead and create a little number line. All right, I'm going to put some hash marks, something like this. Put some arrows. Okay, well, I know my number is negative 2. And then I'm going to put some more numbers, right? So I kind of know where I'm at on my number line. Well, I definitely know that I'm here at negative 2. Because it is greater than or equal to, I know that I'm going to use a closed circle, and I am going to shade to the right. Okay? Why is it? Well, because it was greater than or equal to. Greater than or equal to. So it can be negative 2, or it can be anything greater than it. Okay? Okay, let's get to work. Let's do some practice problems. Okay, so on this first one, when I divide both sides by negative 4, all right, well, negative 4s are going to cancel. I get x. I get negative 2, but what did we do? Oh, we divided by a negative. So what does that mean I need to do? It means I need to flip my sign. All right, instead of less than or equal, it's going to be greater than or equal to. So my inequality is x is greater than or equal to negative 2. And then to graph this, I'm going to mark it negative 2, okay? Because it is or equal to, I know it's going to be a closed circle. Sorry, that is closed circle. And it's going to go to the right. So I need to close my circle and shade to the right. All right, let's keep going here. Oh, let me put a little arrow there. Okay, let's keep going. All right, this next one, m plus 2. M plus 2, negative 1 is less than or equal to m plus 2. Okay, so to solve this one, if we go back to last lesson, or last unit, my bad, I would want to take away 2 from the side with m. So, well, 2's cancel, I get m. Oh, let me actually just do negative 1 minus 2 is negative 3. All right, did we multiply or divide by a negative? No, we did not. So we do not flip the sign. Even though this is subtracting 2, that does not flip the sign. So I would keep the same inequality. Okay? Now what we do have to remember is we do want to have our variable on the left side always, okay? So I'm going to completely flip-flop from negative 3 is less than or equal to m is greater than or equal to negative 3. So there's my answer. And now I must graph it. Okay, let's see. All right, so I'm going to mark it -3. Because it is or equal to, it's a closed circle. So I fill in. Because it is greater than, I'm going to shade to the right. And there we go. There we have it. Okay. Now these can get more difficult and kind of look a little bit more like what we saw in the first part of Unit 4. And that's perfectly okay. All right, let's see. I could distribute, but you know what? I know that 4 and 2 kind of work nicely together. So I'm going to divide both sides by 2 first here. All right, and I'm going to be left with x minus 5 is less than or equal to 2. And then I am going to add 5 to both sides, which will allow me to cancel out the 5s. So I get x is, let's see, did I multiply or divide by a negative? No, so I do not flip my symbol. X is less than or equal to 7. All right, x is less than or equal to 7. Cool. So when I decide to graph this, I mark 7. Because it is or equal to, it's going to be closed. And because it is less than, now I am shading to the left. So I close and I shade. Well, a bad shading, but yeah. Okay. All right, again, they can continue to be a little more challenging, and that is okay. We know what to do. We're solving this all the same. Well, okay, -3/4 times x minus 2 is less than 6. If I saw this problem, I would probably multiply by 4 first, because I don't really like to have fractions in my problems. So if I times by 4, it'll cancel out the 4. So I'm just left with -3 times x minus 2 is less than 24. And here, I know 3 and 24 are kind of nice, work well together. So I'm going to divide both sides by -3. Well, when I do that, sure, they cancel over here, x minus 2. But what must I remember? Because I divided by a negative, well, yes, I know it's -8 over here. 24 divided by -3 is -8. But I must flip my inequality, okay? Really, really important. Finally, I would add 2 to both sides, and I would get that x is greater than -6, okay? So yes, my solution, x is greater than -6, so I mark -6. And now, because it's not or equal to, I leave my circle open, and because it's greater than, I'm going to the right. So I shade to the right. All right, we're getting there, y'all. Let's keep going. About 4 more problems, and then we should be good to go. Okay, let's see. -7x plus 2. Okay, I'm going to start by kind of moving over this plus 2. I'm going to do it by taking away 2. We know how to do that. So I'm left with -7x. I did not multiply or divide by a negative. Okay, so -7x is less than -7. Well, to get rid of the -7, I must divide by -7. And we know what? We divided by a negative. Whenever we divide by a negative, I know that I am going to have to flip my inequality, okay? So, yes, I'm left with x, the -7's cancel. Oh, -7 divided by -7 is a 1. So the only real thing we have to worry about here is that we make sure we flip our inequality because we divided by a negative. So x is greater than 1. Well, I mark 1. I'm open because it's not or equal to, and I'm shading to the right because it's greater than. And so my answer graph would look something like that. All right, let's keep going. Let's change colors. I'm getting sick of blue. Okay, draw my bar. Let's see. For me, I would probably take away 2x from both sides, right? I want to collect all my variables on one side. 6 minus 2. Okay, we got 4x minus 7 is greater than positive 17 because those two x's canceled. Well, now I got to move my 7, and I do it by adding 7 to both sides. So I'm left with 4x is greater than 24. Finally, to get rid of the 4, I divide both sides by 4, and I'm left with x is greater than 6. All right, well, I mark 6. I leave it open because there's no or equal to bar, and I'm greater, so I shade to the right. All right, last 2. Here we go. Okay, 2 does not play nicely with the 9 and the 27, so I'm actually going to go ahead and distribute here. Sorry, bar. So 2x plus 6 is greater than 9x plus 27. Okay, at this point, I'm going to choose, because 2x is less than 9x, I'm going to take away 2x from both sides. Boom. So I'm just left with 6. 9 minus 2, okay, I got 7x plus 27. Okay, I'm going to take away the 27. I got to move stuff away from x. So I take away 27. I'm left with negative 21 is greater than 7x. And finally, when I divide by 7, I get x. Over here, I get, what is that, negative 3 over there. Okay, what's the only thing we got to do here? We got to remember what? We want the x of the variable on the left side. So I'm going to completely flip-flop my inequality. X is less than negative 3. Now, just be careful. I think there's a lot of room for error here. When you get this negative, you have to remember, I don't care that there's just a negative in the problem. Just having a negative is not what flips the inequality, okay? What flips the inequality is if you divide by a negative. And notice we did not divide by negatives. We divided by positive 7, okay? So we're fine here, and we have our solution. So now I plot negative 3. I leave it open because it's just less than, and I shade to the left. Boom. All right, last one. Almost done, y'all. Almost done. Thanks for sticking with me. Well, I can't touch that x until I start peeling back the layers, so I'm going to add 7 to both sides first, okay? When I do that, I'm left with 2x over 3. I did not divide by a negative or multiply by a negative, so now I have 2x over 3 is less than or equal to 2. When I times both sides by 3 to clear out the fraction, I get 2x is still less than or equal to 6. Again, it's less than or equal because I did not multiply or divide by a negative. Finally, I divide both sides by 2. Well, once again, I did not multiply or divide by a negative, so I do not flip my inequality, and I should be good with the solution of x is less than or equal to 3. So here I mark 3. I fill it in this time because it is or equal to, and I shade to the left because it is less than. And that is a rundown of 4.6. I hope that this kind of made sense, and we'll make sure to practice in class. Have a good one.